Hi everyone, welcome to lesson 9-5, Fundamental Counting Principle. We will continue to answer how can you predict the outcome of future events, and we will use the vocabulary Fundamental Counting Principle. Real world link, classes. Tyler wants to take a class at the community center. The table shows the class options he is considering. All of the classes are offered only on Monday and Tuesday. The class that he wants to take are drawing, martial arts, and dance. These classes are only offered on Monday and Tuesday. Both are offered on both days. According to the table, how many classes is he considering? He's considering 3 classes. Question 2. How many days are the classes offered? Only on 2 days, Monday and Tuesday. Question 3. Complete the tree diagram to find the number of different classes and day outcomes. So here we have the types of classes. Okay, we know that he has drawing, martial arts, and dance. So let's include dance there. And we know that you can take each class both on Monday and Tuesdays, Monday and Tuesday. And we have to include the combination of all 3. So let's start here by adding dance. And then we have to add in the days of the week for each one. Drawing is offered on Monday and Tuesday, martial arts Monday and Tuesday, and dance on Monday and Tuesday. So let's fill those in. And now we have to find the combination. So for example, drawing Monday, drawing on Monday, drawing on Tuesday. Those are all the possibilities. Martial arts on Mondays and martial arts on Tuesday. And then we have our martial arts on Tuesday, our dance on Monday, and dance on Monday. So really we have 1, 2, 3, 4, 5, 6 different options. Question 4. Find the product of the 2 numbers you found in exercise 1 and 2. How does the number of outcomes compare to the product? Now remember that the product is when we multiply. So for example, over here we have 3 options on 2 days, correct? So 3 options, 3 times 2 gives you 1, 2, 3, 4, 5, 6. So when you actually multiply your 2 options, you will get all the possible outcomes, all the combinations of them. So really the product, okay, and the number of outcomes are the same. Product and number of outcomes are the same. Now remember what we did in class when we multiplied a die times another die. So a pair of dice would be 6 sides to another 6 sides. And because we multiply those 2 combinations, you have 36 different combinations of numbers to have. And that is the same idea of what this lesson is about. And that idea is called the fundamental counting principle. For example, if event M, right, we have an event, has M possible outcomes, okay, so let's just say it has 3 possible outcomes, and event N has N possible outcomes, we can replace this variable with 2. So let's just say here we have 3, and over here we have 2, right? I'm just choosing random numbers for this. Then event M followed by event N has M times N possible outcomes. This is the example we just did. So it would be 3 times 2, which equals 6 different outcomes. And that's what we had. Therefore, you can use multiplication instead of making a tree diagram to find the number of possible outcomes in a sample space. This is called the fundamental counting principle. Let's look at example 1. Find the total number of outcomes when a coin is tossed and a number cube is rolled. So when we toss a coin, we know that a coin has 2 options, right? 2 sides, heads or tails. And a number cube has 6 sides, okay? So a coin has 2 sides, right? Heads or tails. And the number cube has the numbers 1 to 6. The total possible outcomes is 12, right? Because you can have 6 numbers for just heads and 6 numbers for just tails. So you can see here, we have the coin, heads and tails, and heads has the all the options for number cues, 1, 2 through 6, and tail also has 1 through 6. So together, we have 12 different combinations. You see, or we can just simply do 2 times 6 is 12. If you think you got it, please try this question on your own. Find the total number of outcomes when choosing from bike helmets that come in 3 colors and 2 styles. We have 2 different styles. Maybe one has a rim, like a hat rim, and the other one has no hat rim. You know, like the shade visor. One has it and the other one doesn't. And they all come in 3 colors. Let's just pick yellow, blue, and red. Right? How many different outcomes can you have? Pause the video now and show your work, and then you can play the video again to check your work. Okay, I hope you paused the video. So we have styles, right? One style, let's just put here style 1, and then we also have style 2, correct? Style 2. And for style 1, we have all 3 colors, as I mentioned. We have yellow, blue, and red. Okay, so that's the styles that we have, those 3. Right, so that's 3 options that we have. And then for style number 2, we also have the same 3 options. We have yellow, blue, and red. So it looks like we have 6 different options. When I do my sample, my outcome, when I do it, I go 1, 2, 3, 4, 5, 6, where I have style 1 in yellow, style 1 in blue, style 1 in red, style 2 in yellow, style 2 in blue, style 2 in red. Okay, so really what do we have here? We have 2 styles and 3 different colors. 2 times 3 equals 6. 1, 2, 3, 4, 5, 6. We could have simply have done 2 different styles times 3 different colors is going to equal 6 different possible combinations, outcomes. So really, the fundamental counting principle can also help you find the probability of events. We can use this to identify what is probable in outcomes. So let's look at example 2. Find the total number of outcomes from rolling a number cube with sides labels 1 to 6 and choosing a letter from the word numbers 1, 2, 3, 4, 5, 6, 7. Okay. Then find the probability of rolling a 6 and choosing an M. Okay, so here we go. So we have a number cube and we know that it's 1 to 6. And the letters, we have 7 letters to choose from, okay? So the total number of combinations, if we combine the numbers to the letters and we mix match them all the possible combinations that we could possibly have is 42 different combinations. That's thanks to the fundamental counting principle. There are 42 different outcomes. There's only one favorable outcome though, right? Of getting a 6 and the letter M. So the probability of rolling a 6 and choosing the M is only 1 in 42 chances, or about 2%. Let's look at another similar example. Find the number of different jeans available at the jeans shop, then find the probability of randomly selecting a size 32 by 34 slim fit. It is likely or unlikely that the jeans would be chosen. Okay, we're going to identify if it's likely. Remember, likely has to be more than 50%. Unlikely, less than 50%. So first, let's look at the waist size that are available. We have waist size 30, 32, 34, 36, 38. They're all even numbers. And we have 1, 2, 3, 4, 5. The lengths. Okay, we have size 30, 32, and 34. That's it. The tallest one, the longest one is 34. So only 3 options for lengths. Okay? So 1, 2, 3, 4, 5 times 3. 1, 2, 3. That right there is 15 already. And then we have different styles. We have the slim fit, the boot cut, and the loose fit, the baggy ones. So that's 15 times 3. So you can see here, size is multiplied times the length, which is multiplied times the style. 5 times 3 times 3 is 45. We found that by using the fundamental counting principle. Now, what is the likelihood of, what is the question? What is the is it likely or unlikely that jeans would be chosen? So we're looking for, find the probability of randomly selecting a size 32 by 34 slim fit. 32 by 34 slim fit. So we're looking for that combination. There are 45 possible different combinations. So there are 45 different types of jeans to choose. Out of the 45 possible outcomes, only one is favorable. So the probability of randomly selecting 32 by 34 slim fit is 1 in 45, or again about 2%. It is very unlikely that the size will be chosen at random. I wouldn't say very unlikely, but I would say it is unlikely. Oh no, sorry, about 2%. Yes, it is very unlikely, almost extremely unlikely. Okay, now we get to practice. Let's read through it first. 2 number cubes are rolled. Okay, so 2 number cubes. Each number cube is 1 to 6, right? They're both rolled. What is the probability that the sum of numbers on the cubes is 12? How likely is it that the sum would be 12? Okay, again, so 2 number cubes are rolled. What is all the possible combinations between the 2 number cubes when, and we already know this, that a number cube has 6 sides, right? It's 6 sides. And when you take another number cube, it has also 6 sides. All the different combinations, if you wanted to, each side over here, each number in the first cube, okay? Each number in the first cube. So 1, this could be 1, and it has to match all the different ones from this side. So you multiply them together so that you have 36 different outcomes, correct? You have 36 different outcomes. But the question is asking the sum. We have the sum. So what is the probability that the sum of the numbers on the cubes is 12? So we have to start thinking about all the numbers that can make up 12, right? So we have only 1, because the number goes all the way up to 6, is the highest number. So we have to have a 6 in one cube and a 6 in the other cube, correct? Okay, and that's only one of the probabilities. Therefore, this is only one of them, right? So therefore, it would have to be, there's one chance. How likely is it that the sum would be 12? Well, there's one chance out of 36, right? Or about 3%. I think it's about 2.7, but about 3% chance. So it is therefore very unlikely. Question 4. A box of toy cars contains blue, orange, yellow, red, and black cars. So that's 1, 2, 3, 4, and 5, right? A separate box contains a male and female action figure. So that's 2 options right there, right? So we have 5 options times 2 options. What is the probability of randomly choosing an orange car and a female action figure? Is it likely or unlikely that this combination is chosen? Well, mentally, let's look at this, boys and girls. Mentally, we have 1, 2, 3, 4, 5 times 2. Okay, that's 10. 10 possibility. What is the probability of choosing a female and orange? That's only one combination out of the 10. So there are 10 possible outcomes. There is one way to choose an orange car and a female action figure. It is very unlikely that this combination is chosen at random, because we have 1/10 or about 10%. So yes, unlikely. And here's our guided practice for class. Please take a look through it and make sure that you feel comfortable with these questions. If you don't yet, feel free to go back and look at examples 1 or 2 and 4, 2 to 4. Okay? See you in class, everyone.